Hello AP Chemistry and welcome to 19.7, the last bit of this unit, where we talk about stuff that is, this stuff we haven't talked about yet. As long as you get the gist and as long as you can use the equation, you will be good to go for now, okay? So we have this equation that says, if you look, right, delta G equals delta G standard, right, plus RT ln of Q, right, where this is delta G at standard conditions, right, where we have 1 atmosphere, 1 molar, and 298 Kelvin, and this is delta G anywhere else, right, at any other temperature pressure condition, right? Q is sort of an instantaneous representation of the species present in a system, okay? An instantaneous representation of the species present in the system, okay? It is akin to K, right, where K is our equilibrium constant, and it is essentially, we're going to add a lot of detail later, but it's essentially the relationship between the amount of product to the amount of reactant at equilibrium, right? Whereas Q is anytime the relationship of product, so it's the same equation, right, to reactant, okay? So basically K and Q are a representation of the amount of product and the amount of reactant present in the system, right? Where this is specifically at equilibrium, and this is at any given point in time. Now, if we put in some parameters and say that we are at equilibrium, neither the forward reaction nor the reverse reaction are favored, right? Because if we go back to that diagram here, right, this is equilibrium, right? Once the reaction reaches that point, it's at the bottom of a well, right? So going up is not favorable in either direction, right? Which is why, at that point in time, delta G equals 0, right, and Q equals K, right, which means that this equation turns into this, where delta G standard is equal to negative RT ln K. You should have written down that this is our universal gas constant, 8.314 joules per mole Kelvin, right, and K is this same K over here, right? And G is the same G we've been talking about, right? So if we think about all the math that we know, right, our options, if we have a fraction, right, where we have a numerator and a denominator, right, are that K can be greater than 1, right, or K can be something less than 1, so a decimal value, right? And using our knowledge of natural logs, and even if you're like, I don't remember natural logs, that's fine, because you just need to understand like how a log works, right? So if you remember how base 10 logs work, that's good enough, right? In that when K is greater than 1, then ln of K is going to be, right, some positive number, right? And if this term is positive with this negative, that gives us a negative delta G, yes? So if K is greater than 1, then we have a negative delta G is what that means, right? Whereas if K is less than 1, right, then what that means is that the natural log, or log in general, right, of a decimal value is going to be a negative number. If I have a negative combined with that negative, I end up with a positive delta G, yes? And again, if we take it back to what the fractions mean, if K is greater than 1, that means the place where the reaction comes to rest has more product, yes? If K is greater than 1, then the place where the reaction comes to rest has more product than reactant, thermodynamically favorable, right? Whereas if K is less than 1, that means at equilibrium, where the reaction comes to rest, there is more reactant than product. If K is less than 1, where the place where the reaction comes to rest has more reactant than product, not thermodynamically favorable, yes? All right. So then 1912 says to use the appendix C to calculate delta G and K, right? So basically we would get our delta G, and then we would, right, convert delta G to joules, and then we would plug it into our equation that says delta G is equal to negative RT ln K. Yes? Does that make sense? And then you would solve for K, and that would get you your equilibrium constant for this reaction. And we could use our common sense to make sure that the value of K, right, makes sense with what we know for delta G to be. Yes? All right. We will spend like 3 chapters on the concept of Q and K in a later in the school year, right? But for now, this is enough. You need to understand K is essentially the relationship of product to reactant at equilibrium, right? And what does it mean if K is greater than 1 versus less than 1? All right. Thank you for listening. Be good, and I will see you soon. Bye.